All right, it's 2:10, and welcome back to another episode of Lab for an intro to software engineering. And so, wow, we have two Thomas. So we miss 1, 2, 3, 4, 5. We're missing two people. But I guess we will just start from here. First, does anyone successfully pass all the pipelines for last week's lab? The automatic deploy for the Docker?
I did not. The fix you suggested, and it's still waiting to deploy.
So it's still waiting to deploy, or is it still running?
It's still running, I mean.
Okay, yeah, that's fine. It takes time. It takes time.
Yeah, it's been running for like 22 minutes, I think, right now.
Okay.
And then I've posted on Piazza trying to get my deploy working. I'm having a couple of problems. Jason said that it might be the dashes in my AWS cloud formation, but I removed those. So.
But yeah, make sure you update those in your GitLab variables as well, right?
I did that.
Okay. Yeah, it could be a lot of it's kind of frustrating. It could be any small point that make it fail. So
I'm going to continue working with Jason and you to get that working.
Yeah, so if you have time, yeah, go ahead and then trying to make it working. And if you don't, and then if you're busy with the other stuff, feel free to move on. And we are at this kind of hard time, so we cannot directly see what's happening on your computer, so that it can better help you. But yeah, we do whatever we can do the best, right? So anyway, so I think everyone does a good job on this lab. So at least all of you kind of passed the package package stage in the pipeline. I think that's good enough already. All right. So for today, we're gonna move on to the next topic, which is computer security. And then I think Betsy should already give you guys a lecture on this morning, right?
Yep.
Okay. Yeah. So computer security is another very important component in a real world project. Kind of, we always want to make sure nobody can easily hack into our code or our product or etc. So today we're gonna do a very simple lab on a thing called a buffer overflow, which is actually a very simple mistake we can make when we do the coding stuff. If you don't make sure your code is safe enough, people can easily buffer overflow your code and then hack into it. So today we're gonna do a simple example on this, and then you're gonna have tried yourself. So if you all goes to the lab pad, I already pasted all the lab steps on it. So I will starting with sharing with explain the code we're gonna do. So I will share my screen. Okay. Yeah, I think I want to do where am I? Okay. Go back to here. So the code we're gonna use today is C, and then the platform we're gonna use is a Ubuntu machine, Ubuntu 16.04, and then we're gonna let you to build this machine in your Amazon cloud. So you're gonna create a new machine, new EC2 machine instance, but and then upload all the code and then build it and trying to hack into the code using this buffer overflow techniques. And then later on, we will explain what's happening in the code. And then, so let's goes to the Okay. lab9. So this is a very simple source code to mimic a non-free program that you get to the full version only you paid. If you don't pay it, you get a trial version of the software, right? And then for the paid full version, you're gonna give a serial code, which is a key. And then if you type in the right key, then you're gonna access to the full version. Otherwise, you only be access to the trial version. So in the code here, there's 4 functions, check serial number, full version, trial version. And then there's a main function. In the main function, we're gonna read in a file which contains the key. It could be a wrong key or a valid key. So, and then you do this if statement to check if the key matches with the key that we want. If it matches, you access to the full version. Otherwise, you goes to the trial version, right? So it's quite easy. So, and then what we're gonna do is we're gonna build this program, using a compiler called GCC. I think I recommend using GCC 5. It's a weaker compiler, so we can hack into it. And then we're using a weaker Ubuntu system 16. So what you're gonna see is, you compile this program, and maybe later on some steps. But I'm gonna give you an overview. Is you have this executable compiled for Overflow, and then you're reading a file that contains the correct password, and then it will get into the full version and then print thanks for purchasing. You enjoy the full version software. And then if you give it a password with a wrong, give it a file with a wrong password, then I give it AAAA as the serial number, which is not matched with what it wants in the code. So it will say it's a trial version. Please purchase the full version. So the idea is that we can actually hack into this using buffer overflow, that even if we don't know what is the correct key, we can still access to the full version function. All right. So and in this class, I think we will just give you a very brief overview of how buffer overflow works. But if you are interested in this topic, please take the Introduction to Computer Security class. And it's taught by Professor Dongping Xu, which is next door to Betsy. He's a professional on this hacking stuff, how to hack into, I don't know, maybe he never paid for any softwares. Anyway, so all right, so let's see how we do this, right? So actually, I will briefly explain in the code. What happens in the code is, we're reading a buffer of 512 digits, 512 chars. While here we compare a series number only compare 16 digits, 16 chars here. So if you overflow the buffer here, you're reading, and then when you're reading this buffer here, it's actually not 16 digit. So after this line 9 of the code, you will be able to pointing your memory to the place that it's gonna be get you into the full version, which is line 14. All right. So what we have to do is like 2 steps. So first of all, we have to figure out how many digits we need to overflow this, and then getting to the stack of after line 31. So in line 31, it's called this check, and then returns this value. And then with the return value, we want to give it the memory address that is at line 14. All right, we want to find the memory address in line 14 and then buffer overflow this input file buffer and then give it the address, which will take us after line 31. It will take us directly to line 14 and then get around with this if check statement by buffer overflow the return value in line 9. All right, it's a very brief of how it works, but hopefully you can realize it. It's gonna be depend on your machine. It's the memory address is different for everyone. So in the end of the lab, what you want to see is you with a wrong password, you can get into the full version. Let me show you how it works. So I already created a machine. Maybe you want to create a one too. So let me do the demo first, and then I will let you to try it, and then I will help you if you have any trouble. Let me log into my AWS education account. Oh, by the way, and stop or delete all the stacks in your CloudFormation after the previous lab. It stopped taking credits from me after I close all the CloudFormation servers. I think the CloudFormation servers charge us all the time. No, it still charge me, but way less. So yeah, I realized I only have $72 after last week's lab for some reason. So AWS console, EC2 machine. And then later on, you're gonna create a new EC2. I already created one, so I can start it right now. Instance. Let's see which one. 1604, yes, this one. Action instance start. What's happening? Yeah, running initialization. And I want to connect to this by, and then you better to find this public key which we generated last time, or you can create a new key this time if you when you create a new instance. I using the same key. So let me okay, it is initialization. So in the meantime, I think I will email you the source code. Where I listed you all. Do we have everyone? I think so. to you. It's in no, no, clean it. So it's in the Git. This version. So
Do you want us to just use our personal repo or?
we don't need any repo this time.
Oh, that's right. We're not using
Yeah,
it.
we're just using the machine, the EC2 machine. We don't push it. You just create another folder in your local machine and then put the stuff. Because later on you're gonna be upload all the material to your EC2 machine. Oh, it's still initialization. Let's see. Okay, so let me check into this. Yes, all right. So everybody can see my screen, right? So right now I'm in my EC2 machine. It is Ubuntu 16. So what I do is I build this buffer overflow. So if I give it the correct password, oh yeah, it's not it's attack password. Correct password. It says it's enjoy the full version. So the correct password will enjoy the full version. If it's the wrong password, it says this is a trial version. And then I will trying to hack into the input file and then trying to overflow the input using this attack file. So you can see my series is 1111, but I'm somehow hacking to it. It takes me to this full version software without knowing the correct key. All right, so let's go through it. So this is what you're gonna see in the end of the lab, hopefully. So let's do step 1 of lab steps. All right, in the share pad, you can see step 1 is to create a EC2 Freetime instance. So go ahead and create one. So be sure to select the Ubuntu 16.04, 64-bit x86, and then just hit next, 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 and then it will build a machine for you. All right? And then trying to, SSH into there. And then let me know if you have any troubles. Okay. So I will stop share.
Should we use the key pair that we created for lab 5?
Yeah, just using the same one. So if you can find it in your local machine, if you can't find it, you might want to create a new one. Yeah, for step 2, don't like copy paste that. You have to using your own SSH address, which if you click on the connection, when you create the instance, there's a connection. So share my screen. When you create an instance, there will, if you select the instance, there will be a connection here, and then you click the connection, it will tells you how to connect to your machine. If you're using PuTTY, then there's configurations to do with PuTTY. Chat. Oh, Chris, you already created your new machine with the old?
Yeah, I had an instance that was ready to run, so I just ran it, but now I can't connect to it.
Oh, just create a new one, like the Ubuntu 16.04. It has to be 16.04. If it's 18, it wouldn't work for this lab, all right? 18 is too strong. I think I created 18 for lab 5.
I forget, when we're doing the, when we're SSHing into our thing, do we need to have the lab5.demo pem or our key in the folder?
Yes, you have to have that file in the folder, in the directory that you hit the SSH.
Okay.
Yeah.
Do you want us to also put the file that you sent us today inside of that also?
Yes.
Or can that still be in a separate one?
So it has to be uploaded to your cloud machine eventually. So if you hit the scp command later on, you want to upload that. You can use relative path as well, but I would recommend put everything into a lab9 folder locally and then doing whatever you want there.
Okay.
Okay, so I'm confused as to what section we're reading to refer back to SSH. It said lab 5, step 5A.
Mm-hmm. So it's a reference. I think in step 5A, if you forget how to SSH into a cloud machine, that's where you want to check. If you remember.
Which 5A? Because there's like a part 1, part 2, lab 5.
Just step 5A, I guess. If you goes to lab 5, there's step 5. I think, okay, I see what you mean. Step. Oh. Do we delete anything?
Because I'm about to, I just downloaded a new key pair, but I haven't launched any instances yet.
Mm-hmm. So it tells you goes to the.
Create a new.
It's a connection. Maybe it's,
I think it's 4A in what's labeled under Tuesday, March 3rd.
mm-hmm. Oh yeah, it's 2. Yeah, 4A. Yeah. It just tell you to hit the connection. Yeah, 4A. Yeah, there's a connection button, so you can get here.
Yeah.
So if you are able to SSH into your machine, please hit a 2 in the chat. So let me know you can log in, and then we will move on.
It keeps saying that I have permission denied, and in parentheses it says public key, but I'm not sure why. I'm following all the steps on AWS's website.
Do you create a new machine?
And it says I can do it. Like, what's that? In my
do you
machine,
create
yeah.
a new machine?
Yes.
And then you create a new key pair?
So I have a new instance. It's the same key pair. It's the same lab5.demo key name.
Okay. So do you put it in the directory that you hit the SSH?
In the directory. So do I need a file then? Oh, okay.
Yeah.
That would probably make sense. Okay, that's what I'm missing.
Yeah, you need that file. That is a public key file. You need that.
Gotcha. Thank you.
What was the solution? I'm having the same problem.
So you need to find the file. Do you have the file?
What file?
The PEM file, which it's generated.
I did download that. I downloaded that and I ran chmod on it, change mod to 400.
Chmod, yeah.
It still doesn't let me in.
So yeah, I will suggest you create a new one. Maybe your PM file is expired somehow. Are you sure it is the correct one?
Yep.
Gersi, make sure the name is correct.
Yeah.
Because like one SSH says like lab5.demo.pem, but mine was lab5demo.pem with just.
Yeah, that's what mine is as well.
Yeah. So the one I put in the pad is the name of mine. So yeah, might be different.
That's the error I keep getting.
Are you sure your file name is lab9.pem?
Yep.
That is the one you created in AWS? It's a new one, right? It's a lab9.pem.
Yep. I just created a new instance, and that's the PEM file that came with it.
Oh, that's very weird. Huh. Yeah, I don't know what's happened on your computer. Permission denied. All right, I guess you can try to do all this in your local Ubuntu machine. You have a Ubuntu subsystem in your Windows, right, Gracie?
I do.
Yeah, just try it there then.
Ooh, will
So,
do.
yeah, I don't know which Ubuntu version you have, but
16.04.
oh yeah, that's fine. Yeah, then that's fine. You can just do it there. You know, for the other guys, they don't have a Linux system, so that's why I suggest to create a new instance. So yeah, I think you can just do all the things locally. All right.
So we say 2 if we've successfully SSH'd into the Ubuntu machine.
Yes, if you SSH into that, you say
Yeah.
2. Okay. So I think we missing Max. Max, are you doing okay? Are you there, Max? All right, maybe Max is not there again. Anyway, so okay.
He said, "Give me a second in the chat."
Oh, I see. Yeah, I see that. Yeah, sure. So create an instance, and then let's do step 3, trying to install the compiler, the code compiler in your machine. You know, just do a sudo apt-get update and then do a sudo apt-get install gcc-5 in there. This should be really straightforward. If everything installed, it should shows no error in your prompt and terminal, and then hit the 3 there. Yeah, if you're done, please go ahead and then trying to create a directory for lab9 and upload the file that I emailed to you. You know, the upload script is in step 5, which is SCP instead of SSH. And then it has one more argument to specify the file name, which is the bof.c. And then in the end of the machine account, you also need to specify the address, the folder, the subfolder you want to put your file in your cloud machine. So you need to have this colon delta slash lab9 slash, so it will directly copy the file into your cloud machine in that particular directory. All right. If you finish that, hit F5. If you copied everything onto your
Okay, so that so you does the that second line underneath the SCP line, you have to put that after buff.c?
Yes, that's one
Okay.
line. So it's a line break, I guess. It's one line. It's not two line. All right.
Okay.
Yeah. So you might have some issues upload, just following the prompt arrow, what it says. It could be any typos you have in your command, trying to fix it. Yeah, I just modify the SSH command.
So should we be using our own Ubuntu at EC2 dash whatever?
Sorry?
Should we be using our own, like underneath step 5 with the Ubuntu underneath the SCP? Should we be using our own Ubuntu at EC2?
Yes, using all your own EC2 machine ID. This is my ID. So don't copy paste everything.
Oh.
And then you should do this like locally. So this
You
is
said
yeah. Yeah, this is all my machine address. Right. So maybe that's the issue for Gracie as well. You don't copy paste that. That is my the web address of my machine. You have to have your own machine, which if you hit the connection button in your website, it will tells you the address of your machine.
instead of SSH, it's SCP.
Yeah. So do all this in your local machine, right? Either in PuTTY or whatever the local machine is, and then make sure you have the file in the directory where you're trying to hit this command.
So we're doing step 5 from our local then, not from the virtual.
Yes, not virtual.
Okay.
You are trying to upload the file I email you to your virtual machine using the SCP command.
Oh, whoopsies.
Yeah.
Okay.
Flow.
So how do I get on my virtual machine? Do I just like?
What?
Because I'm in my virtual machine right now.
Yeah, you just minimize the terminal of your virtual machine.
I guess yeah, I can just open up another terminal.
Yeah, just open up another terminal using GC Wing or whatever. You can hit
Okay.
SCP or
Okay, yeah.
PuTTY or whatever. Yeah.
So if we do step 5 correctly, the only thing that should be in our lab9 of our Ubuntu subsystem should be the boff.c.
Yes,
Okay.
You would have a file in your cloud machine.
Okay, just making sure.
Okay. Nice. And then if you have that, go ahead, do step 6, which is compile that source code. Then you can copy paste exactly the thing in step 6, GCC-5.
Yep, it's in there now. All right, so
If the file is there, go ahead and do step 6.
okay, I step 6, which is from the clone machine, compile the source without stat guard protection scheme. So that's in your virtual machine.
Yeah, that's in your virtual machine. If it compiled successfully, you should have an executable there in that directory. Just
buff.
name the BOF. Yeah, okay. So if that hit a 6, so we will wait everyone to this point and then starting hacking into this executable. This is our non-free software. We want to hack into it. Okay. Patrick and Thomas, are you guys following along okay? Max? Okay. Thomas is down. Patrick says, I think Max is close as well. Maybe. Okay, nice. All right, I will share my screen. Now it's all the hack happens. This is the powerful movement that will enable you to do things that you weren't able to do before. All right. So one thing is we want to create a file, and then I recommend using this cloud editor called Hex Editor, which can edit files in this way. So here is the hex. If you guys can see my screen, okay? Everybody can see, right?
Yep.
I'm sharing my screen, okay? So on the right side is, on the left side is the hex code. On the right side is the human readable code. So if we put in, what's the passcode is? cs780, 880. Yeah. 780, 880. It will create this file, and then you just do export. It will download this file. So it's download to my download. You can see this Untitled. I think they disabled the rename function in the website, but we can rename it here. So this is with the correct password. So I would name it, whatever you like, password.pass or password.correct. Whatever you want. And then you create another one, which could be, AABCD, whatever, the wrong serial number. You don't have the serial number, so you don't buy it. And then you export that. I have this, and then I have pass.wrong. So I have this two file, right? And then I upload this to my virtual machine using whatever the same step. So the same step you do in step 5, upload this to machine. You can do this all together. So I do, SCP-I and whatever. Okay, so this is my virtual machine. So anyway, so it's the same as step 5. So you upload these 2 files, and then you can do password.star, which it will upload the 2 files at the same time. Star matches with all the characters. All right, so and then do that, and then trying to run these 2 files with the run these 2 files on your lab machine to see if you can get the first 2 output. All right, so if I run the program with the correct, it will show me enjoy the full version. If I with the wrong, it will show me this is the trial version.
So just type anything you want for the wrong
password.
password.
For the wrong password, because you don't know the
Okay.
serial code. Just put in whatever. Then put these 2 files onto your virtual machine and then run it with the program. If you did this, I think you're at step 8. So hit 8 in the chat. I know that you have seen this.
So and then.
Oh, cool. Many people have done this. All right, then we will do the hack. So the hack is, let me see if I can explain this clearly. I'm not a hack professional, but so, all right. So I'm now sharing my screen. So the hack is we're gonna shift the hex code by a 24 decimal. So the 24. Oh, okay. This is on my Ubuntu machine. 2 minus. So So the hex is the memory address from here, the return point. Actually, it's the beginning of this line and then the end of this line. In the memory, it's a 24 hex digital positions, 24 decimals. We studied this by using GDB, and then we can know that we insert a breakpoint here and then insert a breakpointer after the return. So say here, either in the full form version or the trial version. So basically after this line, it takes 24 digits of memories to shift. So all the things are stored in our memory in the computer and then in the memory stack. So in the memory stack, everything is piped up. You can learn details from Dongping's class, but I'm not gonna explain the details. So maybe I can quickly pull up his slides. So do I have his slides? And we're close here. No, I don't. So, and does Betsy teaches you guys the detail how the code represent in the memories this morning?
I don't think she went over that.
Not that I recall.
Okay, yeah, it's okay. So let me quickly pull up this so you guys can understand what happens here. So basically, we're gonna hack into this file by doing two things. One is the shift, one is pointing it into the function we want to get into. Okay, I'll close this. Security, yeah, highly recommended if you want to be a hacker. This class files. I have the slides full, yeah. Okay. Dun, 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 dun. Yeah. So in the memory organizations, this is the memory stack. So we put our data there. So first of all, we have our code. Then we have these static variables. Then we have these dynamic variables, which is in the heap. And then in the end, there's some scratch papers, unused memories. So everything is lined up in the memory. So we can hack into this code by knowing how it line up by just debugging the code and then see from this line, starting off this line, what is the memory address? After this line, what is the memory address? Then we can get the shift. We know that in the end of this line, it's gonna return to an address pointer. And then there is the place we want to put into the address of this full version function. All right. So we tells you, because this is an easy lab, so we don't want yourself to find the shift. So we tells you it's 24. So we put in 24 bytes here in your hex editor. So this is a oops. So let's choose the. So this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the point where we want to put in the memory address. Everybody see what I'm doing here? So I'm trying to shift the buffer, overflow it. And then at point, it's gonna return our value. It's gonna be return the things here in this blue and hex code address here. And then we need to find the function of full version in our stack memory. So by do that, we have to disable the random space because the operation system has and so nowadays we are in a 21st century, so people know this hack. So they have this randomized things, which every time you run a function, the address of different function is from different. So we have to disable that to realize this buffer overflow. And so doing step 9, you know, this is two line of code. Just copy paste that step 9, and then it will do the step thing for you. And then after you do that, you check that by see the file. So the process system kernel randomize this value. Oh, so I have to do that again. Every time I reboot, I think I have to do the second step. Sudo sys control kernel dot randomize space equals 0. So make sure when you cat is show the content of a file, the variable for that randomized variable space is 0. So it's never randomize anything. So if you can see, if you cat that file, you can see 0, you're fine. All right. Then we want to look at the memory address of the full version, which we're using the name function. So the name, you can name your BOF, your executable, and then it will give you the address of every function. So you can either by looking by ICE. So we go to find the full version. You can see my address here is this. Basically B80640. So this is the code you need, the address code you need. All right, and then this is in a big indent. So we want to convert it into a little indent. So this is you know, some terminologies you have to learn for computer security. So anyway, so what we do is we revert this 2-digit by 2-digit. All right, this is a very crucial step. Everybody can find this well, the full version address.
I haven't done that yet. I was just watching.
Okay, so go ahead. Everybody trying to find it, find your address. And then do step 9. Step 9 and then step 10. Right now, everybody go do step 9 and then step 10. So if you find it, tells me, and hit a 10 in the chat so I know. Okay, that's quick. So I think we'll wait Eli for a little bit. Okay, cool. So now what we want to do is we want to write a new file, which we don't know the passcode. We don't know the serial number. And let's see, share. But we know the address of the full version. Let me make it cleaner by grep. Grep is like a cleaner. So like a search on the output of that. So I grep full version. So this line 4006B8. So basically convert from a big indent to a little indent is just reverse them. So here I do from the last digit is B8. So make sure you edit on the hex file instead of, so this is a memory, this is a hex digit file instead of a human readable thing. So B806 and then 40. That's it. This 3-digit. I don't know what happens. What happens to my hex editor? Let's create a new one. So first of all, do 24 digits here. I do this on the here. Yeah. Basically, you can put whatever here as well. Then I do this B8. Oops. B80640. And then export that. That is my hacker file. So where's my hacker file? So I renamed this is as pass attack, AT attack, all right? ATT or whatever. And then upload that file to your cloud machine. And then using that file to run your executable to see if you can hack into the full version by doing this buffer overflow. So I think that's the last step. If you success, congratulations. If you have issues, let me know.
How did you do that B8?
Do what?
How did you insert B8?
So I insert at the left side of the editor. So I just type here.
Yeah, but when I do B8, it only gets the single value for B. Oh, never mind. Never mind. We're good.
Okay. Yeah, so I think yours should be different, right? Does everybody have the same memory address? I don't think
Mine
so.
was the same.
Oh, your has the same?
Mine was the same as well.
Oh, all have the same 40.
Mine was the same as yours. Yep.
Okay.
Mine's different than yours, but
Yeah, I think you're in a local machine. Yeah, maybe Amazon doing something standard. So everybody get a machine with the same address. Basically, we are doing the same thing in the memory. So anyway. Yeah, and then trying to hack it using your this hack file to see if you can hack into the program. By that I mean you should see the full version prompt. So yeah, you should see some. If you see some sig4 in the end, it's fine. Because it's a 16-digit buffer, and then we're trying to read 24 plus, another 16-digit. So it's definitely be a sig4, but we hack into the software already. Doesn't matter. Okay, if you're done, hit a 12. And then, okay, Max, I will explain. Nice, everybody kind of successfully hacking to this executable. All right, so what happens in the overflow is, oh, no. So yeah, maybe I will just do it locally instead of in this machine. Yeah. cd get cs lab9 oh. So here it's a 16-digit array, right, in line 6. Well, here we're passing a pointer, so it's like the first digit of the array. It gives its address. And then here we define it as a 16-digit. While when we compare this thing, it, you know, when we passing the pointer, when we copy this S into this buffer, we can actually copy more. So the copy, the str copy is not a save function here. So it's actually copy everything. It's just it's copy everything into this buffer. So this buffer is no longer 16-digit, but 512 digit long here. It's go outside the scope of this array. All right, and then this where we have. So how we protect it? So basically, you have to test the length of your buffer. It would be saved here. So first of all, don't make this 512. If you are the coder, you make this 16. Then they wouldn't be able to hack into this by overflow. And then you better test your buffer length here if it's 16. And then another way is put an if statement here. You know, if s put a length here. You know, in this function. You know, int length or whatever, and then you have to check the length of that is less than 16. If it's longer than 16, you don't copy it to a buffer. Otherwise, people can hack into your code. You don't want that happen. So there's a lot to learn for the topic of computer security. Hope you get a brief idea of it, and then. And different companies have a different, you know, policies to prevent this. When you enter into a company, they will have this menu and handbooks, all the thing you have to do in your code to prevent all those lessons. You know, people lost monies on this. So following the menus for your companies, and if you just yeah, all right. Thanks everyone. And then I think we are good today. Well, that's it for me. And I will see you on Thursday. We will move on to another topic of profiling Thursday. Stay safe, everyone.
See you Thursday.
Yep.
Adios, Johnny.
See you guys.